Assalamu alaikum everyone. I hope everyone is going great and must be preparing himself or herself for the exams, upcoming exams, May June 2026 series. And I am with another episode right now in which I am going to discuss the most confusing part of question paper 3, exam 3, practical exam 3, and exclusively for question number 2. While in my previous videos, you have witnessed so many strategies I have explained regarding different aspects, how the examiner will credit you a mark. Again, here we are going to discuss the very important factor, which is in fact a tail ender part of question number 2 for paper 3. And it is actually, and what I'm talking about is the Mr. K factor or a K factor. Well, on a lighter note, I guess, and can anyone guess who is Mr. K? And well, let me tell you who is Mr. K actually. It's me. Behind all these videos is me who is explaining you how to attempt paper 3. But on a real ground, the real K factor is something different and it appears in many forms in past papers. Some of the examples I have mentioned here, I forget to exactly making a reference here right now, but it doesn't matter. Everyone at this moment right now watching my video in the month of the April, and in the last week of the April you have the paper 3 exam. So I must believe every one of you have enough practice on paper 3 for both the questions, so you know exactly what is the drill, how to handle the K factor. K is called constant, although in English the constant starts with C, but we can have the constant K. As in a mathematics, there is a very famous relationship that if A proportional to B, then A and B must have a relationship with the constant K, and the K is the ratio of A to B. Similarly, if A is proportional to 1 upon B, then AB is called K. This K is constant, and this K what I'm actually talking about. So one of the idea, they will actually give you a constant K, a first value of K and a second value of K. And sometimes it happen, if you have a practice from the past year questions, you may witness that they just mention a relationship in words, not in a form of equation. And even they do not mention the space where to write the K values, first and second one. They just give you an empty blank space, right? But doesn't mean that you not have to find the K. You have to properly find the K and write down its value. And K value, while writing a K value, please do not put the units here. We are not expecting a unit for K values. This is one of the idea. Let's see another idea. This is another question. Here they have actually called the K as C, a constant, and get the two values of C, where the K is something else, K, D, and N. The D is some value, perhaps V will be some value, perhaps. Again, I'm really sorry, but I forgot to mention the reference, but somehow they manipulate, like they can change the symbol for the constant. Mostly it's K, sometimes it's C, sometimes it's E, sometimes it's P, could anything. All right. So this is another way. And by the way, there is nothing mentioned about the first value of C1, second value of C1. Similarly, another idea, thanks God, there is a reference, May June 2014, paper 23, question number 2. And here there is another second part, and an additional part for the K factor, for dealing with the K factor. First of all, there is a relationship between T and R where K is a constant, and they have also mentioned that R has a formula, and then they will be expecting the two values of K. But additionally, they have asked you to tell us how many significant figures you will put the values for K. Put the values for K, right? Again, the constant C, again the constant K. You are about to write a value of K. No units, keep this in mind. Number one. Number two, sometimes they will ask you to write a justification for the number of significant figures you are using for the k factor. And always remember, the final k is a calculated quantity, and justification for the significant figures in paper 3 always comes for a calculated quantity, never ever for a measured quantity. So a calculated quantity is obtained by using two or three measured values. Right now over here the measured values are x, y, and obviously the t, either square or t, whatever. So how to write the justification, right? It is here I'm going an ideal answer and in a very natural tune, like how a candidate supposed to write the justification. Since I have used a word measured, never use a word I have calculated, okay? Since I have measured x, y, what else, x, y, and t up to say 3 SFs. Therefore, I have decided to take 4 SFs for the values of k. This is how you are supposed to write the justification. Please mention the name of quantities involved in the formula of k, and the formula of k is k is equals to t square upon r, and put the value of r from this equation here. This is how you are going to write the justification. You understand that? Okay, this is another idea. Again, say they calculate the average speed of the water in the tube using the relationship and justify the number of significant figures that you have given for the value of v. Although v is not a constant, but v is a calculated value, and it is being calculated by using a value of d and t. Again, you can use, since I have measured the d and t up to 3 or 2 or 4 SFs, whatever the SFs you are using according to the instrument provided, I have selected 4 or 5 SFs for the values of v. Yeah, value of v. If you have taken one value to value of v. Okay, this is how you're going to write the justification. All right, now once you get the 2k values, how you gonna further proceed? Well, then we are expecting, if the candidate has a constant, and I have just mentioned here, yeah, mathematically, if two physical quantities have a relationship either directly proportional or indirectly proportional, then mathematics suggested that they must like generate a constant k. Now for the values of, let's say, a1 b1 k, a2 b2 k, a3 b3 k, according to mathematics, if the different sets of a's and b's are put down in this relationship, they must generate constant k. If the k is keep changing its value, it means the relationship is doubtful, right? So same way, if I am getting the 2k values and I found a difference in it, that the k is not similar, okay, one, yes, just one thing click in my mind. Writing the two values of constant or a c, whatever it is, student used to round them, and I have just explained, guys, that you have to extend the significant figures. Never ever round the k, final k kabhi bhi round nahi hota. You should remember this. All right, because students usually in this pursuit, like in mind, okay, like if they can round the k, they might have a similar k or a same k after rounding it. Then if they are asking you the justification of significant figure, then what's the point of rounding the k value? So remember this always, okay? Never ever round the final k factor in order to just make them similar. but definitely you will find a difference in 2k values. So when you get the two different values, you have to show us the working of difference percentage in the 2k values, which is delta k upon k average, and delta k is k greater minus k smaller, k average is k greater plus k smaller divided by 2. And I found how to support a relationship. You will first in step 1 mention us the idea of getting the k difference, delta k difference, and then in step 2 you can, in three different ways, you can write a relationship by linking the difference percentage in 2k values with the existing percentage uncertainty of a quantity in the formula of k. This is one of the method. Then the method number 2 is that the difference percentage with the standard limit of accuracy, that is 20%. And the third one is link the delta k percent with the existing percentage uncertainty of k itself given in the question. I have figured out these three different form methods kept repeating their self in the past year questions, where we are, where for the for this particular area, how you have to write an answer, it depends which way you are going to choose. It all depends in what instructions are given in the question. Let's take some quick examples about it. Okay. All right. First of all, find a difference percentage, because supporting the relationship needs three steps. Step number 1, find a percentage difference. Step number 2, start thinking to make a comment, right? Or start thinking for the selection of a specific criteria, and then write this statement. The percentage difference in 2k values is either smaller, is greater slash smaller than the percentage uncertainty of alpha used for calculating k. Alpha I am just quoting here for an example, okay, or beta or gamma, whatever, for calculating k values. Hence my results does not or does support the suggested relationship under the limit of experimental accuracy. If the difference percentage is greater, my result will not support. If the difference percentage is smaller, my result will support. This is now first way. Second way, the percentage difference in 2k values is greater and smaller than the standard limit of accuracy. Hence, my results does not or does support the suggested relationship. Well, for way 3, because I have mentioned way 1, way 2, way 3, right? If you select this criteria, what statement you have to write? It's mentioned here. If you select this criteria, what way, how to write the final statement, you will have this one. For way 3, let's wait for a little. I will explain directly from the past year question. Now look at a question over here. May June 2013, paper 34, question number 2. A relationship between v square, which is kl, where k is a constant. Explain whether your results support the suggested relationship. All right, now I have mentioned this one in the next slide. Over here, how we gonna write an answer? Look at it now. Look it down. In this particular example, V is the average speed of the water in the tube of internal diameter d, and given as 120 upon pi d square t. Wherein in part A2, the reference is here, May June 13, paper 34. You can take this paper in front of you, or maybe in your mobile or in tab, or in a parallel screen, and then you can start comparing this one. I have just making some assumptions here. In this very same question, in part A and double I, the percentage uncertainty was asked by the candidate from the examiner. And let's say the percentage uncertainty in the value of D has been calculated to say at 3%. On the other hand side, the percentage difference between the two k values is 5%. And candidate should write the answer like the delta k percent is sorry, not smaller. I must made a mistake here. The delta k difference is greater than the percentage uncertainty of d. Oh, okay. Why it's smaller? I got it. No, it's correct. Why? Because in the formula d has a square, and we have obtained a percentage uncertainty as 3%. And you know the theory, guys, if some quantity has a power and also a percentage error, then because of the power, the percentage must be multiplied by that value of power, which is 3 to the 6. Whereas the difference percentage is delta k 5. So if you write, yes, there is a little typographical error made by me, I'm just clearing it. The delta k is smaller than the percentage uncertainty of d square used for calculating the k. Hence my results support the suggested relationship under the limit of experimental accuracy. This is how you're going to write the answer. Got it? All right, you can rewind it and just listen again and again and again so that it will be understand by you. All right, next, way 2, reference October number 11 paper 35 question number 2. There was a situation here, a water and a resistor dipped in a water attached with a voltmeter as well, right? And pour the water from the measuring cylinder, get the mass, estimate a percentage in the mass. It is suggested that the relationship between v theta and theta 2, theta is probably a temperature. That first theta 1 is the temperature before putting the resistor, and then second one would be after that one. But all these details you can again find it in the question paper. All right, now look at the formula for the k. V square, voltage square, right? Voltage square, and then 2 temperatures. Where the hell is m? Because the percentage uncertainty is asking, they are asking the percentage in the value of m, but m is not somehow related to the final k factor. How you gonna write the answer? So now guys, way number 2, sometimes the different percentage in 2k values has to be related with the standard limit of accuracy, which is 20%. And for that, smaller and greater, how you gonna write the answer? Are you getting this? So see, reference is there, k is there. How are you gonna write the answer? The difference percentage in 2k values is either greater or smaller than the limit of accuracy, which is 20%, and my result does not support the suggested relationship. Okay, sorry. Again, a little typographical error. For greater does not support, and for support it should be smaller. Sorry. For support it should be smaller. Yeah, swap ho gaya hai, typographical error hai, excuse me for that. All right, so 2 methods I have explained. Now go for the way 3. It's a exam style, well, like it's a recent exam question, May June 2025, last year question, paper 23. It is suggested that relationship between t, d, n and x is like this, where k is a constant. And I have mentioned as a nb in this question, is not an art, is a part A and 2. The percentage uncertainty is required for d, where d would be definitely some quantity, right, which is already mentioned in the formula for k. Because when you make the k subject, you will going to write like this: t square dot x square divided by dn. It means in the formula of k, the percentage uncertainty is involved. Now look at the third method. Instead of going towards the idea of percentage uncertainty like in the previous part, what are you gonna do? It is suggested that the percentage uncertainty in the value of k is already done for you guys. That's 15%. It has already been done for you. Using this uncertainty, explain whether your results support the suggested relationship in part E or not. So now what you gonna do? Obviously, you first of all take the delta k percent. I'm repeating for you: greater minus smaller divided by average, multiply by 100, take out this percentage. Now the difference in 2k values is greater and smaller than the provided uncertainty of k in the question. Therefore my result does not or does support the suggested relationship. This is how you will complete your statement. Okay, so this is how you are going to deal with the k factor. K, Mr. K, like me, is quite a typical factor, and you have to understand this one. So keep repeating from wherever you have missed anything, just rewind it, play it back again, and record it, and see the recordings so that you can fully understand how to deal with this particular k part. All right, thank you very much, and inshallah in the next video, that would be the last part of this series of videos where I'm going to discuss the limitation and improvement for the very last part of question number 2. Thank you for watching. Is again, do not hesitate to subscribe and share my videos, and best of luck again. Thank you.